Now, if we draw a Cartesian plane, and somewhere on that Cartesian plane we draw a line that goes through the origin, we call this a ray. So you could label this, write it a little bit bigger, sorry. This is a ray. Now, a ray is the position of a line that goes through the origin on the Cartesian plane. Now, it only has one position, wherever it is that you draw it, but wherever you draw it, it actually corresponds to many angles. Now, to find what these angles are, you have to start at the x-axis. So all positions are named according to where they are relative to here. We call this 0 degrees. Now, if you move anti-clockwise this way, however big the size of that angle is, that's how you describe the position of that ray and how you describe that angle as a positive number. So I've written that here, moving anti-clockwise, you can measure the angle as a positive number. But moving clockwise, you can also get to the same place. So if I started here, let's use another colour, and I went around this way, I could also measure this angle and describe that as a negative number. So when we're moving clockwise, we have a negative angle, and when we're moving anti-clockwise, that's this way, we have a positive number. Now, you can do laps of the Cartesian plane and still arrive back at the same place. So if you started here on X, you might go all the way around, do a full 360, and then do this bit again. You'll arrive at the same position. And that explains why when you do laps, you can basically arrive at the same ray, having added or subtracted 360 to either of those measurements. So if you need to pause the video now to take down these notes, do so now. And let's have a look at a quick example. Now, what this means is that any one position has many angles that correspond to it, but every angle only actually has one position. So let's just take a ray like the one that we just drew, and let's say that this is 70 degrees here, this angle. Now we want to name all of the angles that are associated with this ray. So if we moved clockwise, that gives us positive numbers. So we can name this 70 degrees. We could also do a couple of laps, couldn't we? So if we went a full 360 around and then we did that 70 again, we'd have 360 plus 70. So we could also name it 430 degrees. What if we'd done another lap? We could go all the way around, do 720 and then our 70, and we'd have 790. And so on and so on, every single time we add 360 degrees. But at the same time, we could also describe it, we'll use another colour, let's use black. We can describe how to get there from 0, remember this is point 0. If we go this way and this is 0, these numbers here are minus 10, minus 20, minus 30, we're going minus, aren't we? So minus 90, minus 180, minus 270, we could get around to here. Now how big is this angle? This would be 20, wouldn't it? So if we start here and we go around 180, 270 plus 20, then we've gone 290 in a negative direction. So we could also call it minus 290 degrees. We could also do another lap, a full 360, and we'd add 360 onto that. So we get, what's that, 650 degrees minus 650. We could then do another lap all the way around until we get there, and it's going to be another 360 on top of that. So that's going to bring us up to what, minus 1010 degrees, and so on, subtracting 360 degrees every time. Now here we've made these look like two different ways of getting to the number, if you like. But if you have a look, going from each one here, we're subtracting 360, and going to each one here, we're adding 360. Have you noticed that if you add 360 to minus 290, you actually get 70, don't you? So you could describe this, let's use a different colour again, as one set of numbers. You could start wherever you liked and say this, the angles that correspond to this ray here, let's start with the smallest one we have. In fact, let's start by saying dot, 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 because there's many that come before it, comma. We've got minus 1010, minus 650, minus 290, 70 degrees, 430 degrees, 790 degrees, dot, 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 dot. And those will go on in both directions, subtracting and adding 360 degrees. Let's look at another example. Say we have a ray that's sitting here. And this angle is, no, let's make it something different. Let's make it 30 degrees. We can describe the angles associated with this ray as, well, this is going in a minus direction, isn't it, from 0? So we'd start with minus 30. But if we wanted to get there by going in the positive direction, we could have started here and gone all the way around 330, couldn't we? And then we can go around again, adding 360 to that, and then adding 360 again. And we can also take 360 off, so that the one that comes before that would be minus 390, and there'd be more that comes before that as well.